Hi, this is Raju here, and so today I'm thinking of starting teaching mathematics of class 12. And the major book I will follow is just NCERT. But before that, I would like to discuss some prerequisites sites to prerequisites for class 12 mathematics. So, for example, let's say in mathematics, so for, let's discuss first syllabus what we have here. Give me just a few minutes. Just 1 second. So let me write the syllabus over here. One is first chapter you have to read about relations and function. Your second chapter would be inverse trigonometric function. Trigonometric function functions. Third one is matrices. Fourth is determinants. Fifth one is continuity and differentiability. Continuity and differentiability. Sixth is application of derivative. So all these 6 chapters belongs to part 1. In the second part, so till this what you have part 1. Part 2 of your syllabus will be like 7th chapter is your integrals. Chapter 8 is application of integrals, and then chapter 9 is differential equations. Differential equations. Chapter 10 vector algebra. 11 is what? 11 is 3D geometry. Right? So we have 3D geometry. 12 is linear programming. Last one, 13th is probability. So all these are the chapters we are going to read in class 12, right? So, but we will majorly divide all the chapters into three parts. So one we can say about calculus, right? Calculus. So if we see what comes under this is basically your function relation things, all kind of functions, and uh, derivative or differentiation, integration, integration, and things related to this. Second part you can have like algebra. Spelling is not correct. So in that you can have this geometry things. No, not geometry. Algebra means matrix, yes, determinant, and vector. All these comes under this algebra. Third one is your geometry, right? It's only 3D. Fourth one you can say something miscellaneous. I think LPP also comes into calculus because it involves integration things. So LPP comes under this. Vector algebra, geometric 3D, and yeah, trigonometry. Yes. So I think before teaching all these things, we should have some basic knowledge of we should know how to solve. First thing is that be very comfortable trouble in solving equations, in solving equations, right? It can be a single variable linear equation, single variable linear equation, and you can have double variable or any number of variable linear equation. Then also a quadratic equation, or you can have combination of many equations or trigonometric equations, we can say. Just write it here. Trigon. I think this would be a little bit difficult, but yeah, we can have knowledge of this too. How to solve trigonometric equations. Yeah. Another thing is the next step we can say that about representation of mathematical. So let's write just mathematical representation. So mathematical representation. What exactly is this? So for example, let's say we have a decimal system, right? So it's nothing but a set of 0 to 9 digits, and using this you can write any number. Now when you have number, you can represent all these into different way. So let's say if you have something, right, you can write same thing as a means you can if it is very big, then you can approximate it's 2.5098 into 10 to the power 4. So this thing you have to be very comfortable. And another thing is about this radix, right? Like power things, right? So if you have a to the power m into b to the power m, you should be able to stretch nothing but ab to the power m or similar things. You have to be comfortable in all these things. So one is solving equations, mathematical representation. Third thing, so I think logarithm comes under this. Yeah, means power radix logarithm or exponential things. It all comes under mathematical representation. And then plotting, plots of so some basic of function. Let's say discuss some uh, basic function and its plot. This thing. So this include, let's say, for example, you have a straight line, right? Straight line. You can have a parabola, hyperbola, ellipse, right? You can also have trigonometric function. Although all these things will be discussed in function chapter, but you should know all these things, right? And also, not even what yeah means equation and inequality, yeah, and inequality. Trigonometric function, then a modulus function, trigonometric function, modulus function, what others remaining? That means this way you can have different kind of function that we can discuss. Like the one thing is called signum function, step up function, step down function. So this thing we'll discuss later. But yeah, all these things has to be very clear and be comfortable in solving equations, inequalities. You means and also set theory. Yeah, it's very important to understand set theory. So yeah, this has to be very clear. Like what is meaning of union, intersection, like a subset. So and also we need to know how to represent intervals, right? So we have 2 points A and B. So something can lie between this, right? Something can be from this start from A and it's less than B. So we can have different kind of scenario and something, and we should be able to represent what exactly is that. So these things should be very clear. So based on all these basic thing, this will help you to understand different representations used in function relation and also in differentiation integration. So you can have a problem of limit, yeah. So you should be able to solve that. So I think from today is the overview of a discussion on the syllabus and what we need to understand before going into the each chapter. Yeah, so let's add another section. So or another page. Yeah, another page would be I think better. So here we will what we should discuss, I think, representation, right, of different way of representing a number. Yeah, this would be fine, and some rules to represent that. Representation of numbers. So before that, we need to understand some different class of numbers, right? So what are those things? For example, there is something a natural number, and we can have whole number, right? Natural number, whole number, another thing. Not, I think prime, co-prime are not important over here, and rational number, yeah, it's very important. Rational number, we need to also understand complex number, operation with complex number, natural number, whole number, rational number, complex number. Yeah, real number, yes, real number. So first thing is real, would be your real number, then natural, whole, rational, complex. So yeah, so this thing we need to be very clear about. So let's discuss first thing like a real number. What is this? Yeah. So basically it's a number which can be represented on number line. So number lines means you can have, let's say, this straight line, and let's say you have some interval here, right? Now any number which comes on this line, it can be exactly at interval or in between interval, it's fine. Let's say if we assign this particular position to 0, then this side we can have positive number, this side we can have negative number, right? Now if something is here and if something is here, this is called, at this these positions are called integrals, right? Integers. So this can be in both direction, means just after, just right to this reference or 0, or left to this 0. So right side you have positive integer, left side you have negative integers, and now you can have something in between that, right? Something in between that. So what are these something, right? So these are like called fractions, fraction, right? Now if we have set of both fraction and integer, right, then that is called your rational number, right? Now even in terms in integer, what we can have, let's say this is integer, right? Or say positive integer. So here we can have two things. One is called whole number. Whole number. So what is this? Is a 0, 1, 2. It goes up to infinite. So it's an integer but started from 0. Now what exactly is natural number? It's called counting number. So in counting you start from 1 to 3, right? So yeah. So it starts from 1, 2, 3. It goes to infinite. So now you are aware that this is what is whole number, natural number, integer, positive integer, negative integer. What do you mean by fraction? If something come in between two integer, that is your fraction, right? So all these numbers can be represented on real number, right? So all these are the parts of what? Real number. Now there can be something which is called complex. Let's see here, right? So what exactly is this? Let's say this is your real number. No, this is your number line, right? You have this origin. Now you have 1, 2, like that, and this side you have -1, -2. Now just imagine you have a number that cannot lie on this line. It can come here, somewhere here. right? So basically, if you see what exactly is, it's a one-dimensional representation, right? It's a 1D representation. 1D. D means dimensional. Let me write it. One dimensional flow, you can say. So what if you have two-dimensional flow of numbers? Let's say you have plane now, right? You have plane, and this is your origin. So basically, this line, this horizontal line represents your real number line. Real number line, right? Now there is something called imaginary number line. This vertical line represents imaginary number line. What is this? I will tell you. Imaginary number line. Yeah. So what exactly is this? That in mathematics or physics, if you see something as gain, then and you also have something as a loss, and if you have to represent both things together, so right. So then what you can do? Let's say this represents your gain, right, and this represents your loss. So you have you gain something and you lost something. So what exactly you have, how you can say that? Now to answer this kind of question, you have to have some set of system that can easily describe this kind of scenario. So in that you have something called complex number, right? So let's say here you have this point, right? You have this point. Now if you see, it's just like a coordinate geometry, right? So if we take projection of this line on this particular axis, we have this point. Now it is far from origin, it is this much far. Now again from origin, this is this much up, right? So this way we can have something which is gain, which is loss, which is positive gain, which is positive loss, or any two different kind of things, like. So in physics, basically this line represents dissipation, right, and this represents something stored energy. Now so this point, so this system is called complex. Now if you see, this point is not lying on this real number line, so it is between this real and imaginary line, or exactly this point comes over here, right? There can be a point which is totally on imaginary number line, not in between any of two. So or you can have a line that is totally on this. So you have now set of all these things which comes under complex number, right? So how we can denote all this? Let's say this point is A, this is B, then we can write what is this point? It's A plus IB, right? So this represents a complex number. This A can be anything, B can be any real number. A is a real number, B is a real number, and this I represents what? So this is the second part is saying it's imaginary part, and the first part is a real part. Okay, I hope in short you have understood what is complex number and what is real number. So we discussed the rational number is basically what the set of integer and fraction. We discussed natural number, whole number, real number, complex number. So if we have to make a tree, then what will come on top? So let's see. So basically, what we you have complex number, yeah, right? Now below that, what you have two things. One is real, another is imaginary, right? Totally real to imaginary. Now in real, what you have, right? Rational number, right? You have rational number. Let's delete this line. So yeah, in rational you have two things. One is called integer, Another is called fraction. Both can be positive and negative, right? Now, so it can be positive, it can be negative. Now I'm not discussing even or, right? So that's a different thing. Now an integer, positive integer, what you can have, one is called natural whole, right? Integer. In negative, we don't have any concept like natural and whole. It's just integer, or you can say again here we can have positive fraction, can have negative fraction. There are other things also in case of fraction, like something is proper fraction, improper fraction, that I'm not going to discuss. So if someone has interest, that can look into that. Yeah. So these are the three. You have to be very aware, right? From here, from this to this, now come to this, and this, up to this, and finally you can come to this, right? So these are the things that you have to be very aware. Yeah, this is one, let's say this is part one of understanding representation of number, or how number system has been developed or divided. Next thing is that, let's say we have number, right? So sometimes you can see that something is written, let's say as 2 to the power 5, something is written as 0.001, right? Something is, so what exactly is this something, you can say this log, um, mm, what we can say, let's say log 1000, right? So yeah, so these are the things. Again, what are these are just representation, different way of representing some numbers, right? So here we have used radix, here we have used fraction, here and also we can have something like 2 into 10 to the power 20, like that. So again it comes under this power. So this is called something logarithmic. If a number is small and we want to have big interval, so the interval can be, let's say if we have number right here, so this is linear interval, right? If you see what is this, it's the difference between each point is fixed. But what if I say that let's say your difference is decreasing, right? So let's say it is now, this is your first difference, second difference, third difference, fourth, like that. So if we have something like this, right? The so now if we see the number that is represented by each cap is not same. It's varying, right? It's varying with particular uh, power, or it's a power of 10. Then this is different way of representing, and it comes on the logarithm. Logarithm. This comes under you have this all this simple representation natural number. Yeah. So next thing, let's discuss this power thing, radix or power, we can say, right? So what exactly is this, like there are few rules over here. Let's say if we write something like this, so what is a, what is m? So a is called base, m is your power or radix, you can say, power or radix, right? And we used to say that a raised to power m, this thing. Now here if we do some operation, like we can have addition. First thing, let's say addition. A double D I notice spelling over here. Let me check. Give me 1 second. Mathematical. Yeah, it's fine. I think it's true. It's correct. Addition, subtraction, multiplication. First one is division. So again, when we do all these things, we should have at least two set of number, right? And let's say we have what a one is a to the power m and the b to the power n. We have two numbers, right? And what we can have different scenario, right? Let's first discuss addition or subtraction. It's fine. So if we are going to add e to the power m plus minus b to the power m, right? Now let's discuss about different cases over here. So the case one, right? Case one is what? A not equal to b and m not equal to n, right? Case 2 can be what? A not equal to b, m equal to n. Similarly, case 3 is what? A equal to b and m not equal to n. Case 4 is like A equal to b and m equal to n. So I think this is not important case 4. Mainly we can have these three, right? Which are very important. So what is first case here, right? What is first case? Let's change the color. Case 1. We have two number a to the power m, b to the power m. So a not equal to b and m not equal to n. Now how we are going to do addition or subtraction, right? Or any mathematical operation, right? So let's say first add or sub. What we can do here? So if we are writing this, right, plus or minus, now we cannot perform any further steps. So it will remain at this point only. That's it. For example, if we are writing, let's say 2 to the power 5 plus 3 to the power 6. See, one way is to that if we know what is 2 to the power 5, let's say for example, it's now 32 plus 3 to the power 6, it will be a very big number, then we can write something. Or we can stop here only. I think it's better to stop here only. Now I have taken this example as 2 or 3, it's a small number, but you can have large number, bigger number. So in that case, it would be very difficult to calculate. So please stop it over here if this is your first case, right? Even if you have multiplication like that, let's say if you are multiplying a to the power m into b to the power m, right? Now you just write a to the power m, b to the power n. It's same thing. You just omitted this symbol, right? So this would be your final answer. Similarly, if you are dividing, right, a to the power m divide b to the power n. You can stop over here or you can write same thing in a different way, right? A to the power m into b to the power minus n. So what is this minus n? This is nothing but if you have something 1 by b to the power n, you can write this thing as a minus n, right? B to the power of minus n means what? 1 by b to the power n. So I have used this thing here. So you have to stop here only. Now there is no need of doing calculation or anything. Just stop it. So remember this thing, this formulation. This is very important. Now, so you understood the case 1. Now let's come to the case 2. What is case 2? Let's see. A not equal to b. So you have two numbers, a to the power m, b to the power n. And what is the condition here? A is not equal to b, but m is equal to n. Now you will see something very interesting. So let's say m equal to n equal to some k, right? Then what we can write here, a to the power m equal to a to the power k, and b to the power n equal to b to the power k, right? Now if we have to add this thing, right? Let's see addition subtraction in a different way. Let's say here addition and subtraction. What we can do here, right? So if we are adding a to the power k plus b to the power k, right? Now here not, we don't have anything to take common, right? Or we can further write this thing. Let's say if we will take b to the power k as a common thing here, right? Or a to the power k common. Let's say I'm taking a to the power k common. Then what we will have here, 1 plus b to the power k divide a to the power k, right? Or you can proceed with something like a to the power k into 1 plus. Now what is this? B by a power k, right? Yeah, so this thing we will discuss into the division, how we come to this. So you can do, in addition you can do only this step. Now when you have multiplication means what? You are going to multiply what? A to the power k to b to the power k, right? So what you can see here, your k, your radix, your power is same, but your base is different. So you can easily write a into b, right? And the whole power k. It's simple, right? It's very simple. Similarly in division, what you can write, if you have a to the power k divide b to the power k, you can easily write a by b to the power k. And you need to understand use of this bracket. This is a small bracket, always use this kind of bracket. So when things come, things are not individual, they come into the group, you have to use this k, this bracket, right? So the a to the power k divided b to the power k is equal to a by b whole power k. That's it. So you understood this thing, right? Hmm. Now let's discuss case 3. So you have two number, a to the power m, b to the power n, and the condition is what? A equal to b, but m not equal to n. It's different, but a equal to b. Now let's say a equal to b equal to some number. Let's say x, right? Then what you can write this a to the power m as, right? X to the power m. Similarly, b to the power n, you can write x to the power n. Now, how you can do addition? Let's say discuss addition here, right? First, addition or subtraction. What you can do? So if you are doing x to the power m plus minus x to the power n, right? So what you can do, same thing I think you can do, just take anything common, x to the power m, you will get 1 1 here plus minus x to the power n by x to the power m, right? From previous property what you can write this thing, so 1 plus minus. Now things is very interesting here. So see, you have x to the power m minus m, right? We will discuss this thing later. What exactly is this? I'm underlining this. Yeah. So addition subtraction can proceed with this step. Let's discuss multiplication and division. Delete it. Multiplication and division. What is this? See, I'm going to multiply this thing, right? So your base is same here, right? This is same x, but these are different. One is m, another is n. So what we will write here, it is going will be equal to, keep your base same thing, and if you multiply here, your power will be added. So what you can write, m plus n, right? Or simply just write x to the power m plus n, right? So if you are multiplying, what if you will be dividing, right? In that case, your base is same, so keep this thing same. Divide means what? It's nothing like, let's say it's very simple, right? X to the power m into 1 by x to the power n, right? And we have said, I already said what is meaning of this 1 by x to the power n is into multiply, we can write x to the power minus n, right? Now what we can write this thing, x from this previous property, m plus minus n, right? This thing we can write. So plus again we can what write, x m plus minus minus n, right? Equal to let's write x to the power m minus n. So what you can easily write here, same thing, x to the power m minus n. Yeah. So this way you can represent any number, right? Your x can be any number, m can be any number, n can be any number. So I think I have discussed all the scenario here and the representation of different numbers, power. Another thing is logarithm. Let's discuss shortly here. Logarithm. What is this? Give me 1 minute. Yeah. So let's say we have some representation, right? We have a number a, and this is equal to what? B to the power x, right? So you understood what is meaning of power. If you have repetition of the same number in multiplication, you can write that thing as power, right? So now, is there any different way to write same thing? So if let's say someone is asking that, question is like what would be the power of x? Oh no, what would be the power of b that makes it equal to a? If you have this kind of question, right? So in that case, if you have to say about this power, right? This power. So if someone is asking what is the power of b, what is that number? If we put as power of b that will be equal to a, the answer, the representing this question is what? Is like x equal to log b a, right? So what exactly this is saying? Let's write something here, and so the a here is called argument, and this b is called base, right? Now, hmm. So the a is argument, b is base, and x is what is called log of a, which has base b. So this is representation of this particular thing in different ways. So if someone asking, I said already that if someone is asking what is that power which is on b, and that makes this whole term equal to a. So that question that comes if we have or something log b a, x is what equal to log of a, or we can say log b a, right? So for example, right, let's say if someone is writing, now if your base is 10, let's say b equal to 10, base is 10, right? What you can write here, and some if someone is asking if you have to find log of 1000, log of 1000 base 10, what it would be? Now see, this is your 10, base is your 10. Now you have to say on radix, we have some number x here, right? X, what will be that number x, so that this is going to be equal to this number, right? This is going to be this number, right? So if we are writing 10 to the power 1, we have 1 10. If we are writing 10 to the power 2, we have 100. It's not equal to that. If we are writing 10 to the power 3, that's 1000, right? So it's equal to this. So now in place of x, what we have? 3. So the answer of this will be 3, right? So 3 is what? There's 10 to the power 3 that will be equal to this particular value. So the log 1000 is nothing but it's equal to 3 if its base is 10. Yeah. So this way you can understand things. Let's say if someone is asking what is, if your base b is 2, and if someone is asking log 64, right? 264. Now you have to see what 2 to the power, right? Here what you will put here so that it is going to be equal to 64, right? So if you are writing, let's say 2 to the power 3, right? No, I should not write here. Let's say it's 2 to the power 3. What is this? 8. 2 to the power 4 is 16, right? 2 to the power 5 is 32. 2 to the power 6 is what? 64. So now this 6 will come here. 6. The answer of this will be what? 6. I hope you understood logarithm. Right. Now this is definition of logarithm. Like we in exponential or power representation, we have different way of writing like mathematical operations. Similarly, we can also have same thing. Now I think should I discuss that or not? I think that we should not discuss that thing here. It's it would be enough to know what exactly meaning of logarithm. So now when it comes in the question, then we can discuss in more detail. Or I think we should write formulas of all these things. Yeah, the very important thing is let's discuss. So if we are writing something, let's say log k equal to log 8x, right? So the based what would be x and what would be a, right? Or let's say if a is 10, right? A is 10, so it is called common log, right? If A is E, what is E? It's called a Napier's number, or it's a number, right? So then we can say this thing as a natural log, right? So the value of E, E, yeah, and it is represented as log, and it is represented as ln. If someone is writing ln 10, that means what is the base here? It's log e 10. If someone is writing log 10, right, then it means log 10 10. So you have to be very clear about this thing, right? Hmm. Now I'm going to write some properties here. What is, let's say first one is like if you have log a1, so it will be always 0. So any number to the 0 is going to be 1, right? If you have log a, it's 1, right? A to the power 1 is same number a. If you have 2, if you are doing product of two numbers, so your base is m, your base is a, and you have m and two different numbers, then what you can have, it's simply, so see, you are multiplying here. So here if in expansion, what you can do, log a m plus log a n, simple. If you have log a division, right, m by n, it's a subtraction here, log a m minus log a n. Yeah, so I think these two rules are very important. VVI, very very important. Another thing is called base change rule, right? So what is that? Let's say if you have log b, uh, log b a, you can write what, log ca divide log c b, or what you can write, log I think that is not correct. Hmm, I think it's fine. So what we did that we introduced some different numbers C here, and if we have this log CA log CB divide. So now the question, can we do multiplication in similar way? Ah, it's same thing. I think same equation is written here. Okay, so this is one property. Another property what you can have is that if something have, let's say, a log a to the power x, it is nothing but x. Yeah. Another rule, let me write here. We have a space here. Log a to the power n, an, and no, I think leave it. Hmm. So this is end of what? First prerequisite. If you come to this slide, right? So I have completed this thing. This thing. In the next class, we will discuss how to solve different equations. That will be very short. 1 hour will be enough for that. So we will stop recording here. Thank you so much for having patience and watching this video. If you have any question, you can ask